as you can see, now I'm starting up the RV's application, and then now the AGV robot is actually placed inside a class which is used to represent an area of a factory. And as you can see, I am manually controlling the AGV to map around the class so that it knows, so that I get the default, the area, so that I could set the waypoints for the AGV robot to follow later on. And you can see I've saved the map into the class map PGM. Moving on, I'll run a script which I've written, which is for the user to load the maps that have been saved just now and decide which point that they want the AGV rover to follow. So as you can see, user can press on the plot and then drag their mouse to also decide which area that he or she want the rover to face, such that the camera can inspect or look at the thing that the user wants. So you can see everything is plotted and then closed and then everything is saved. Moving on, all of the thing will be closed down and launch the nav2 node. Then as you can see, the map have been loaded. And then initially, before the launching, the post estimation have to be given so that the inside RVs, they know actually where is the robot right now. As you can see, the robot is actually at the corner of the class over there, and then the post estimation is also given there. And moving on, I will load the script that I have written, which is the waypoint following script, where it will load the YML file, which contains the waypoints that have been set by the user just now. So after it loads, the script will send the waypoints to the RV's nodes and control the scuttle to move one by one following the waypoints that have been set. And that's all from me. Thank you.
This is a demonstration of the anomalous detection using thermal imaging and machine vision. The main object is the stepper motor, which is powered by this circuit and it's controlled by the Arduino Uno. It will be used for a demonstration, and this is a Raspberry Pi 4. It's connected with the MLX90640 camera and powered by power bank. The phone is used as a camera. The phone sends the frames to a computer, which then uses a machine vision model to detect the object. In this case, it's a motor. The thermal camera extracts temperature information. The median temperature is 32.96, which falls in the range of normal operating condition for this motor. I've manually set the normal operating range to 32 to 35 degrees Celsius. And this is what it looks like for the thermal imaging. So as the thermal camera and the camera collects information from the motor itself, it stores them into a folder locally on the machine. There are annotated view, temperature data, temperature image, and also normal view. So this is an example of the annotated view. And then this is the example of a normal view where there is no annotation. And in addition to that, I can train a model based on the data that I've collected. Okay, so it's finished training. So I give an example output of what the model will look like. There's a difference between the model and without the model. The model uses statistical analysis, like they use standard deviation to determine what is the optimal temperature for a machine to operate. For example, if I go to annotated view, there is optimal and not optimal. Let me go to optimal. So as you can see, it can differentiate between what is optimal and what isn't.
First, we have two microphones. They are going to perform dual microphone noise cancellation. Let's look at the live FFT waveform for now. As you can see, when I put a noise source towards mic 2, you can see that the FFT waveform has a response. And when I put the noise towards mic 1, the FFT has the same response. So now, on the top graph, it's going to be a noise cancellation technology waveform. And on the bottom graph, it's going to be the original signal. As you can see, when there's only 1 kHz signal, the algorithm does very, very well on noise cancellation for this 1 kHz signal. If I increase to 2.2K, as you can see, it's still performing very, very well. Next, let's move on to the machine learning model. I've trained a machine learning model that can recognize audio signature of a fan, and it will perform inferencing on the given input file. The audio input will be from the mic array just now, so let's look at an example. So this one is an input file on the trained dataset, and it's abnormal. So when the code runs, it will generate a spectrogram. As you can see, this one is a spectrogram of an abnormal fan, and it will generate a result. So this result will have a file name, time, and the result of detection, which is abnormal. Let's move on to normal. This one is normal. Change the name of spectrogram, and we can run again. So as you can see that there are differences in their spectrogram, and for the results, it got overwritten. So the time has changed, and as you can see, the results of detection is different as well.
The dashboard is a web application running on PHP server. It communicates with the device over HTTP LAN connection. The dashboard starts with the device management, where we can add the devices. Once we have the devices, we can add maps to those devices. For example, this is one of the map that we are setting up. So we can set up the coordinates to inspect by clicking on them, or configure them manually in these input fields. We can name them, and these coordinates gets converted to actual coordinate using this ratio. Once we have the map set up, we can start an inspection using that map. We can start now or later. For example, this is one of the inspection running. When inspection starts, it starts with navigation. Once the navigation completes, it triggers acoustic and vision model, and it keeps repeating for all the points. So if we go inside, we can see the live location here, live view, and these yellow dots mean those locations have problems, and green means everything's okay in those locations, and red dot represents the current location of the device, and we can see here all the data here. This is the vision model data, this is the current location picture, and this is the audio. And if we want to see what happened at certain location over the time, we can analyze them from here. For example, new point, device inspected by device 1 at warehouse at this location has 3 inspection points. These are the data we can see in the graph. These points also show what happened at those locations using the message, and we can either click here or here to check the data at those locations. Lastly, we have the incidents listed separately, so we can easily take a look at them. And we have the home page summarizing the last week's details. Finally, we have the bot here, which helps the user to answer basic questions.